Good morning. So let's we continue our discussion on acids and bases. Last time we discussed about the characteristics of strong and weak acids and alkalis. Today we are going to discuss what happens to the ions in neutralization. Of course, neutralization, you remember, neutralization means what? The reaction between acids and bases, or acids and alkalis. An acid can be neutralized, that is, its acidity can be declined by an alkali to produce a salt and water. This is the general formula for neutralization. An acid mixes itself with an alkali and it's going to give you what? Salt and water. The most common and famous example is, for example, hydrochloric acid in an aqueous form. It mixes itself with sodium hydroxide to give what? Sodium chloride and the water. Yes, so this is simply what? Neutralization. Yes, all these compounds are completely ionized except what? For the water produced. The hydrogen ions coming from where? From here, from HCl. The hydrogen ions from the acid and the hydroxide ions, the OH, hydroxide, the OH negative, from the alkali have combined to form water molecules. Yes, this ionic equation for neutralization, this is the ionic equation for the neutralization. Yes, that is H plus OH minus will give you what? H2O. So this is the ionic equation for neutralization. We left the chlorines and the sodiums. Why that? Because they are called what? They are called the spectator ions. Chloride and sodium remain in solution, which becomes a solution of sodium chloride. So they are spectators. Which one? The sodiums and the chlorines. But the hydrogens and the hydroxides, they are actively exchanging electrons in order to give us what? To give us a new substance or compound, which is what? Which is the water. Yes, so simply this is the neutralization diagrammatically represented. You can find it in figure 5.29. Yes, so this is neutralization. I think you know it. Okay, from neutralization then we can get salt. By evaporating some of the water, the salt can be crystallized out. In fact, the same ionic equation can be used for any reaction between an acid and an alkali. Okay, for any reaction we can write the same type of an equation. Yes, so this is neutralization. Neutralization is what? The hydrogen is going to react with the hydroxide to give us water. So that is the ionic equation for any neutralization. In this reaction, the acid is providing hydrogen ions to react with what? With the hydroxide ions. So this is it. Hydrogen ions will react with what? With the hydroxide ions, and they will give you water. In turn, the base is supplying hydroxide ion to accept the hydrogen ion and form water. This leads further definition of an acid. So we can give what? A better and stronger definition of an acid based on the transfer of the hydrogen to the hydroxide to make water. So what are you going to say? Acid is a molecule or an ion that is able to donate proton H ion. Proton H ion is a base to a base. Base is a molecule or an ion that is able to accept a proton. A proton here, the proton means what? The hydrogen. The hydrogen, as you know, it has what? It has only one electron in its in its outer shell. Yes. If that is going to be donated, then simply that hydrogen is going to be changed into what? Into a proton. Yes. So an acid is a donor, and a base is what? An acceptor or receiver of electrons. So this is another definition of what? Another definition of acids and bases. Okay, the basicity of acids. Okay, all right. This is another topic. Consider two things: sodium carbonate and sodium hydrogen carbonate. These are two salts, sodium carbonate and sodium hydrogen carbonate, two salts, are both salts of carbonic acid. That is, they are originating from this acid. What is the name of this acid? Carbonic acid, H2CO3. Therefore, this one acid is giving two different types of what? Salts. Two different salts of this acid exist because there are two hydrogen atoms present that can be replaced by a metal. Yes? Yes, all right. So there are two hydrogen ions, so these two hydrogen ions can be replaced by two metals. So carbonic acid is said to be dibasic acid because it has what? It has two replaceable hydrogen atoms per molecule. Dibasic acid. What does it mean? This means that dibasic acid means an acid when it is neutralized, it can give you what? Two different types of salts. Yes, it's not only carbonic acid which has this property. For example, let's consider sulfuric acid. Let's consider this sulfuric acid. Now this sulfuric acid it mixes itself with one molecule of NaOH. It gives you what? Sodium hydrogen sulfate. In here it gives you what? Sodium hydrogen sulfate. But in here, when it reacted with two molecules of NaOH, it gave you what? It gave you sodium sulfate. Therefore, even though the parent acid is the same, that is, even though it is sulfuric acid, but it is giving you two different what? Two different types of salts. As a result, we call such kind of an acid dibasic acid. Hydrochloric acid, nitric acid, and ethanoic acid are all mono. Mono means what? One. They will give you what? Only one type of an acid. They have only one replaceable hydrogen atom per molecule, and they each produce only one salt. Phosphoric acid is a tribasic. Tri means what? Three. That is, it can produce three types of salts. Since the acidity of a solution depends on the number of hydrogen ions,